Nothing goes away. We just keep adding to it. So we don't change anything. We just add to, just like the inverses. Quadrant 3 is off limits. That doesn't mean quadrant 3 has gone away off the face of the earth. It is still there. We can still use it. We just can't use it for inverses. And I'm going to say that over and over and over again to where you're annoyed with me saying it, so that way it's a test and quiz day. You'll remember that, and you won't get any of those wrong. All right, so yesterday we did inverse sine, had restrictions in, they could be in quadrant 1 or 4. So the cosecant inverse is the same. Secant is the reciprocal of cosine. Those are the same. So what's nice about those is we can change our inverse cosecant and inverse secant to inverse sine and inverse cosine if we flip the side. That's the reciprocal. Reciprocal means 1 over, and then 1 over means that we flip it and just do like what we did yesterday. Cotangent, we could do the same thing, but there's 2 reasons I don't do that. First reason, mainly, is because the quadrants are not the same as inverse tangent. Inverse tangent, your 2 quadrants, it could be in 1 and 4. Cotangent is 1 and 2. The other reason I don't do it, because y over x, x over y doesn't save me anything. There's no benefit in changing x over y versus y over x. But for cosecant, remember, sine of an angle equals y, cosecant of an angle equals 1 over y. Well, if I change cosecant to sine, then I just have to look at the y versus 1 over y. So I'm back to what we did yesterday. So that's why I do that. Now remember, when we take the inverse, we're not taking the inverse of the side. Okay, we're taking the inverse of the whole function. So it's inverse cosecant of pretty much hypotenuse over opposite, and that equals some angle. Yesterday, it was the inverse sine of the side, which is opposite over hypotenuse, and that equals the angle. Okay, so the inverse sine doesn't change the side. The inverse cosecant is what flips what's inside. The inverse switches the x's and the y's. Let's go back to Unit 2. When we did Unit 2, and we first graphed y equals sine theta, we put in 0 for theta. We got out a 0 for y. All right, we inputted an x, and we got out a y. Now we're flipping those 2 and finding the inverse. So that's what we're doing. We did that yesterday. We're going to do the same thing today. We're just going to add the other 3 inverses to it. First, let's start with the calculator. So calculator is not quite as easy as it was yesterday. Yesterday, pretty self-explanatory. There's a button for it. Today, there's not a button for it, and it's different than what we did in Unit 1. Okay, because remember, we're taking the reciprocal of the side. And the reciprocal of the side is not 1 over the whole function. It's just the side. So this is inverse cotangent of adjacent over opposite. And that's going to give us some angle. Well, we don't have an inverse cotangent button on our calculator, so we have to use inverse tangent. Well, if we use inverse tangent, the inverse tangent of the reciprocal of that. Well, 0.523, what's the reciprocal of 0.523? 1 over 0.523. That's going to give us our angle. Now remember, this is always going to be just a value, so it has to tell you degrees or radians. We are in degrees because the directions tell us to. So we type in our calculator the inverse tangent of 1 over 0.523, and that's going to give us our answer in degrees. And you should get 62.39 degrees, or 390 degrees is fine also when rounding to the thousandths. The reason I knew to degrees is because the directions told me. If the directions said radians, I would need to be in radians. So on these inverses, the directions have to tell you what mode to be in. The calculator can be either. I will tell you, every non-calculator problem we do, we will always ask for radians. Right? Every non-calculator problem we do, we'll always ask for radians. You really, really need to get comfortable with radians, because if you're going to calculus next year, everything's in radians. I don't think there's anything in degrees. Okay? It's almost all in radians. So, following that same pattern for secant, there's no inverse secant button on our calculator. So we type in secant cosine, and then 1 over that number. So we could do 1 over negative 1, it doesn't matter where the negative is. As long as there's one of them, if there's a negative in the numerator and the denominator, that makes it positive. So all that matters is that the negative is in the parentheses. And then when you do that, you should get something. Let's think about before we do this. Where should that angle be? So we have restrictions. We can only be in 1 or 2. So our answer should be somewhere between 90 degrees and 180 degrees, because that's where secant and cosine are negative, and I think it's 112.796 degrees. Again, we can kind of figure out what our answer should be according to our restrictions. And then the inverse cosecant, so that would be, we would type in secant sine of 1 over 1.062. And again, we're in degrees, 70.325 degrees. If you get something like 0.637 degrees, most likely you're in the wrong mode. So check your mode on these. And then number 4 really could be done without a calculator, but since we have a calculator, we'll go ahead and use it. What we type in is the secant sine of negative 1 over 2. Notice that's something we did yesterday. Hopefully we recognize that as something we did yesterday, the inverse sine of negative 1/2. So again, we could do that without a calculator, but since we have one, we go ahead and type that in, and you get negative 30 degrees. Again, does that make sense that we have a negative angle? Well, let's think about our restrictions. Inverse cosecant or inverse sine, both have to be in either 1 or 4. The calculator is set up for principal value. You don't have to tell the calculator you're finding principal value. If I am writing it on the paper, I have to tell you principal value. But the calculator, automatically, just like automatic has order of operations, it's automatically will only find the principal value. So this negative should be down here in quadrant 4. Remember, we can't go into or through. Put your phone away, or I'll take it away. Can't go into or through quadrant 3. So it makes sense that if we're in quadrant 4, the answer is going to be somewhere between 0 and negative 90 degrees. So negative 30 makes sense. The only thing that could be different with that are these next ones, and it tells you to put it in radians. So it's the exact same thing, you're just putting it in radians. So what you type in your calculator is the inverse tangent, so 1 secant tangent, 1 over 3.557, inverse cosine of 1 over 15.268, inverse sine of 1 over negative 1.056. And again, we're in radians now, so we have to change the mode. That's all that changes. So there are your answers you should get, all rounded to the thousandths. Be sure you round to the thousandths. The thousandths means you look at the 4th number. You don't look at the 5th and change the 4th and change the 3rd and keep going like that. You only look at the 4th number. The 4th number will change the 3rd number or keep it the same. Those are your only options. Don't start way at the end and just keep changing. You look at the 4th number, and the 4th number will tell you if the 3rd number stays the same or goes up 1. So when you're studying for your test, quiz, whatever it is, be sure that you study and go over this and know how to put it in. Because it can be easy points, but if you don't look at this, it can be impossible to remember how to put it in, because it's not that self-explanatory. You have to think a little bit. If you know all your reciprocals back from Unit 1, 1.8, then it's pretty easy. But the inverse is a little bit tricky sometimes for people. All right, so now without a calculator. Okay, so we're going to find the exact, and that should say principal value, the exact principal value for the expression. If your answer is an angle, answer in radians. The reason it says if your answer is an angle, because sometimes we're going to have those double ones. And if we have the double ones, sometimes your answer is an angle, sometimes it's just a number. If it's just an inverse, then your answer will always be an angle. Or it could be not defined. All right, so the inverse cotangent of root 3. Now, cotangent is one that I don't change to tangent because mainly the restrictions are not the same. Inverse cotangent can be in either quadrant 1 or 2. Quadrant 1, it's the positive. Quadrant 2, it's the negative. Okay, because cotangent is x over y, and that's going to give us an angle. Okay, it's the inverse of the side, and since we don't have a calculator, and we know there's a root 3 on our unit circle, we're going to deal with the x's and the y's. So really what we're looking for is where is x divided by y equal to the square root of 3. That's what we're looking for. And we know it's going to be in quadrant 1 because it's positive. Because quadrant 2, if we change this to negative root 3, then we would be looking in quadrant 2. All right, so look at your unit circle. Only places where that could even happen are at pi over 6 or pi over 3. Those are the only two places where there's a root 3 involved. So at pi over 6, the coordinate is root 3 over 2, 1/2. At pi over 3, the coordinate is 1/2 root 3 over 2. Now, I'm showing a lot of work. This does not require you to show any work at all. Okay, we want you to show work, but a problem like this, you can just look at your unit circle and write the answer. I'm just showing you how I get to that answer, because if I just wrote the answer, some of you might not know where that came from. All right, so x over y. So we're going to say that's root 3 over 2 divided by 1/2. I can't divide fractions, so I multiply by the reciprocal. 2's cancel, and I get root 3. So there's my answer. Pi over 6. If you had changed that to the inverse tangent of y over x, 1 over root 3, that'd be fine. You just have to recognize the original problem was cotangent. Tangents are in 1 and 4. Cotangent is 1 and 2. So it'd be fine, but you just have to go with your original problem's restrictions. And that only is an issue with tangent and cotangent, because secant and cosine, cosecant and sine have the same restrictions, so you can change them, which I'll show you. That's what we're going to do here. All right, so the inverse secant of negative root 2. If we were to do that in the calculator, we would do the inverse cosine of the reciprocal of this. So negative 1/2. Now, we don't have to do that. I just think it's a lot easier. I found it to be much, much easier to deal with sine and cosine versus secant and cosecant, because I'm looking for where on the unit circle is 1 over x equal to negative 2 versus where on the unit circle is x equal to negative 1/2. I can just look and figure that out. So where is x equal to negative 1/2? That original problem would have been where is 1 over x equal to negative 2. It's the same thing. This is that, but those two are equivalent statements. They mean the same thing. Exact same thing. If you cross multiply solve for x, you get the same thing. All right, so we're in quadrant, let's see, we are in quadrants either 1 or 2. It's negative, so we're in 2. So we're looking for where is x equal to negative 1/2 in quadrant 2. Look at your unit circle, and you get 2 pi over 3. So in dealing with the reciprocal functions, it's the reciprocal of the sides. The angle stays the same. The angle is never the reciprocal. Pi over 3 is always pi over 3. It's the x's and the y's that can flip-flop, not the angle. The angle is the angle. All right, inverse cosecant. So this is another one. Because our restrictions match up to our inverse sine restrictions, we can change that to the inverse sine of negative 1 over root 2. If we want. You could find where is 1 over y equal to negative root 2, or just where is y equal to negative 1 over root 2. Now, this goes back to yesterday. We talked about the square root of 2 over 2 equals 1 over root 2. Square root of 3 over 3 equals 1 over root 3. If you can know those, when you just recognize them, looking at them, it'll be much, much easier for you to do these problems. And you won't accidentally say not defined because you can't figure out what rationalize or unrationalize is. I do not care if you rationalize or not. But in this problem, you have to recognize, you could change this. If you don't like that unrationalize because it doesn't match anything, that means the same thing. These two are equal. These are all equal. They all mean the same exact thing. So we are looking down in quadrant 4. Remember, we cannot go into or through quadrant 3 ever for inverses. Only inverses. Into or through quadrant 3 for inverses only. Quadrant 3 still exists. It hasn't gone away. All right, so we look for where does y equal negative root 2 over 2. And that's going to be at negative pi over 4. 7 pi over 4 is where that happens, but 7 pi over 4 makes us go through quadrant 3. We can't do that. We cannot go through quadrant 3. Therefore, we have to start at 0 and go down, which is a negative direction. Again, back to unit 1, knowing about positive and negative angles. All right, cotangent. I'm not going to switch that because there's no benefit. The restrictions are different, and y over x, x over y doesn't save me any time. So my restrictions, it can be in either quadrant 1 or 2. Very important to know those restrictions, because if you get those restrictions wrong, then all of your answers are wrong. It's like switching x and y. You get switch x and y for cosine and sine, everything's wrong. You get your quadrants wrong, maybe quadrant 1 you'll good, but the other two are all be messed up. So we're looking for where is x divided by y equal to negative 1. Well, hopefully we know that if something is going to be a 1, the x and the y have to be the same. So the only place that the x and y are the same are at the pi over 4s, 3 pi over 4, 5 pi over 4, 7 pi over 4, negative pi over 4. The x's and the y's are the same with opposite signs, so x divided by y, that happens at 3 pi over 4. Because you just have to know your restrictions. You have to memorize your restrictions. And those restrictions are what makes it a function because we're finding the principal value. So that's just all there is to it. No, you have to know your restrictions to know where to go. And these two match up with their reciprocals. Tangent and cotangent are reciprocals, but they don't match up. Inverse tangent was 1 and 4. Inverse cotangent is 1 and 2. Okay? So that's why I don't switch those, because their restrictions do not match up. And x over y, y over x doesn't save me anything. All right, now the double ones. So cosecant times the inverse cosine of negative 0.4. Well, how in the world would I do 0.4 without a calculator? 0.4, you would say, that's how we say it, but that's kind of, I don't know, slang for 4/10. If we want to say that correctly, that is 4/10. All of us can write 4/10 as a fraction because we need fractions. We need opposite over adjacent, hypotenuse. We need all those sides. Sides are a ratio. 0.4 is not a ratio. Now, if you want 0.4 over 1, now you're going to just have more fractions to deal with, decimals in fractions at the end. You can't have fractions in fractions. You can't have decimals in fractions. So, cosecant of cosine of -4/10. I write it exactly how I would mathematically say that. 0.4 is what we say, but really that is considered 4/10. Now, I always like to simplify at the beginning if possible because I don't want to multiply big numbers at the end. It's a lot easier to recognize how to simplify things at the end is if you deal with smaller numbers. There's nothing wrong with keeping it 4/10. It's just when you do your a squared plus b squared equals c squared, it's going to be a little bit bigger. All right, so we ignore this cosecant at first. So now we're back to a problem from yesterday. If this ratio of the sides isn't on our unit circle, two options. Either it's not defined, or we have to draw a triangle because it's not on the unit circle. Cosine is adjacent over hypotenuse. Adjacent to hypotenuse is 5. That works. If it was the other way around, wouldn't work. So we draw a triangle. In quadrant 2, you have to draw the triangle in the correct quadrant. That would be quadrant 2. Your angle, that's what we're looking for. That is all we care about. We don't know what it is. We can't figure out what it is without a calculator, but we don't care what it is. We just care where it is. So now we're really finding the cosecant of that angle. Well, in order to find the cosecant of that angle, we need to know hypotenuse over opposite. So that's where these numbers. So the inverse cosine is adjacent, so we know adjacent is -2. We know hypotenuse is 5, according to the problem that was given to us. Then we do -2 squared, which is 4. I'm going to say y squared since it's the one that goes up. Doesn't matter what letter you use. Equals c squared. So y squared equals 21. Y equals plus or minus √21. I have to decide, do I use the positive or the negative? Since I'm going up, I use the positive √21. So my answer, cosecant of that angle, is 5 over √21. If you don't like that radical in the denominator, 5 √21 over 21. It's fine. Does not matter if you rationalize or not. That 1 over √2, √2 over 2, 1 over √3, √3 over 3, you have to recognize those. But when you're writing your answer, you do not have to rationalize. You have to simplify. Simplifying a radical, rationalizing are two different things. If that was √24, we would need to simplify it. But simplifying is different than rationalizing. All right, this next one, maybe. Take away that inverse tangent for a minute. Or inverse sine. We're right back to unit 1. 1/2 times the tangent of 3 pi over 4. So 1/2 the tangent of 3 pi over 4. 3 pi over 4, the tangent y over x. So we get -1. So we're taking the inverse sine of -1/2. Now we're back to yesterday's lesson. Restrictions are either in 1 or 4. Because it's negative, we're looking in quadrant 4, where is y equal to -1/2. And that's going to be at negative pi over 6. Not 11 pi over 6. Okay? Yes, does that happen at 11 pi over 6? Very true, but we cannot go into or through quadrant 3. It is off limits, so we have to start at 0 and go down, and that's how we get negative pi over 6 for that answer. After pi, 7 pi over 6, 5 pi over 4, none of those will be answers. From 7 pi over 6 all the way to 2 pi, those aren't even answers for inverses. Again, that doesn't mean it's off limits. It's off limits for inverses. Only inverses. Quadrant 3 is still there. Quadrant 4 is still there. Just inverses, we cannot go in that direction. Here's an example of that. Secant of 5 pi over 4. What a lot of students want to say is, quadrant 3 is off limits, we can't go in there, so not defined. That is not true. Secant of 5 pi over 4 is a unit 1 concept. It's just the secant of some angle. So we go to 5 pi over 4. Secant is going to be the reciprocal of the x value. So we just flip the x value. X is equal to negative root 2 over 2. 1 over x is going to be the reciprocal of that. So this would be negative 2 over root 2. It's 1 divided by x. 1 divided by negative root 2 over 2. We can't divide fractions. We can't keep fractions in fractions. I've told you all year it's going to be wrong. You have a fraction and a fraction. I'm not even going to look at it. It's wrong. No complex fractions. No decimals in fractions. No fractions in fractions. Ever, ever. Okay? All you have to do is take the reciprocal. You don't even have to do all that multiply by the reciprocal. You just take the reciprocal because it's 1 over. So now we have a problem like we did today. Inverse cosecant. 1 or 4, because it's negative, we're down here in 4. So we're looking for where does 1 over y, or let's do this, make it a little easier. Flip that back and change it to inverse sine. So now we want to know where y equals negative root 2 over 2. So all we do is look in that middle one right there. We cannot go through quadrant 3. So we have to start at 0 and go down and get negative pi over 4. So you'll notice these answers are going to keep happening. There's only so many answers. I think we counted earlier. 13 possible answers here without a calculator. So you have notes, 2 days of notes. You have homework. You have a quiz. So things are going to happen over and over again. You're going to see some things that continue to happen. Now, if it's something like this, there's an infinite number of those we can give you. But again, it's just drawing the triangle or possibly it being not defined. We ignore that cosine for a minute and we say the inverse tangent. Okay, so the inverse tangent is opposite over adjacent. Well, it's just a 5. How do we make a 5 a fraction? How do you make any number a fraction? Correct. Put it over 1. Anything you can make a fraction that's rational. Okay? Anytime you have something that doesn't have a decimal that repeats forever, that's the only thing an irrational number you couldn't. So any number you have, you can put it over 1. So 5 over 1, is it possible for the opposite and adjacent to be? Yes, because it has nothing to do with the hypotenuse. The sides can be whatever they want them to be. So tangent is up here in quadrant 1 where... Say that again. Inverse tangent is 1 and 4. Inverse cotangent is 1 and 2. Okay? All right, so opposite is 5, adjacent is 1. Whoops, that's not adjacent. 1. So a squared plus b squared equals c squared. 1 squared plus 5 squared, so 1 plus 25, 26. Square root of 26. 26 doesn't have any factors that are perfect, so we're good. So remember, we're looking for the cosine of this angle right here. This equals an angle. That angle we found. We don't know what it is, but it doesn't matter what it is. We're not looking for the angle value. We're looking for the cosine of that angle. So the cosine of an angle, we're back to adjacent over hypotenuse. So adjacent is 1, hypotenuse is root 26. You don't like that radical in the denominator? Root 26 over 26 is fine.
Did you know that the triangle was
Because of the positive. Because inverse tangent is either 1 or 2. So if we made that a -5, all that would do is flip it down here. Would that have, if this was -5, would that have changed our answer at all? No, because we're still doing adjacent, which is 1 over 26, so it wouldn't have changed it.
Wait, is inverse tangent in quadrant 1 and 2 or 1 and 4?
1 and 4. Inverse cotangent is 1 and 2. Yesterday was tangent 1 and 4, so that's why when I see cotangent and tangent, I don't change cotangent to tangent because the restrictions are not the same. All right, and then the last one, secant times the inverse sine of -12 over 13. So hopefully we look at that 12 over 13 not on our unit circle. So all that means is either it's not defined or we have to draw a triangle. Sine is opposite over hypotenuse. So opposite's okay to be smaller than the hypotenuse always. It's negative, which takes us down to quadrant 4. Opposite hypotenuse, and the opposite has to be negative. That's a triple. If you don't remember that triple, you just have some multiplying to do. 13 squared equals -12 squared plus x squared. And now all we do is take the secant of that angle right there. This equals an angle. That angle was that angle right there. Doesn't matter what it is, just matters where it is. Secant is hypotenuse over adjacent. So we get 13 over 5. Now, what if I change this word to cosine? What would that change? 5 over 12. Could I have made it tangent? -12 over 5. I could have made it cotangent. -5 over 12. Okay, so I could have made it sine. If I made it sine, -12 over 13, they kind of cancel. Sine and inverse sine cancel each other, so it would just be what it is. Okay? All right, so that is the